The James Webb Telescope has uncovered something truly terrifying, an ancient star that didn't just die but transformed into a cosmic eliminator. This monstrous star, over 20 times the size of our Sun, exploded with such force that it tore through the very fabric of space. Now, the remnants of this early supernova are exhibiting strange and unsettling behavior. What could a star this massive have left behind, and how did its destruction reshape everything around it? Brace yourself, because what James Webb just captured might be a grim confirmation of our planet's own impending fate. Scientists have labeled this ancient explosion as AT 2023 ADSV, which sounds more like a computer error than a celestial event, but make no mistake, this thing was huge. It happened when the universe was just a baby, around 2 billion years old, still trying to get its act together. That means the light from this explosion has been hurtling through space for over 11 billion years before reaching us. Back then, the Milky Way wasn't even a thing yet, and our Sun, nowhere to be found. The universe was a chaotic mess of forming galaxies, exploding stars, and raw, untamed energy. Before we dive deeper, one thing is certain. This explosion didn't just shape the universe. It may have unleashed something far more destructive. And what comes next will leave you stunned. The discovery came from JWST's Advanced Deep Extragalactic Survey, a fancy way of saying scientists pointed this ultra-powerful telescope at deep space to see what was hiding in the cosmic shadows. What they found was a relic from a time when the universe was still wild and unpredictable. Supernovas like AT 2023 ADSV weren't just rare, they were different from anything we see today. In our era, a dying star tends to follow the same routine: burn through its fuel, collapse, and either leave behind a neutron star or a black hole. But back then, the first stars in the universe didn't play by those rules. Those ancient stars, called population 3 stars, were unlike anything we have today. They were enormous, burned way hotter, and lived much shorter lives. And when they finally reached their breaking point, they didn't just explode, they detonated with unimaginable force. At 2023 ADSV wasn't just a flashy cosmic event, it was a wrecking ball, blasting heavy elements like carbon, oxygen, and iron into space. Before explosions like this, the universe was mostly hydrogen and helium, nothing more than a sea of the simplest elements. But supernovas like this one changed that, filling space with the raw materials that would later build planets, moons, and eventually life itself. But this explosion wasn't just big, it was off the charts violent. Researchers say it unleashed nearly twice the energy of the biggest supernovas we see today. That level of destruction means this star wasn't just massive, it was something completely different. The key might be its lack of metals. Unlike modern stars, which contain heavier elements that help regulate their energy output, the earliest stars were made of almost nothing but hydrogen and helium. That made them unstable, burning through their fuel way too fast and ending their lives in the most extreme way possible. The wreckage from AT 2023 ADSV wasn't just scattered into space, it became the foundation for everything that came after. Every planet, every moon, every asteroid floating around today likely contains some material from explosions just like this. Even the iron in our blood, that had to come from somewhere, and it sure didn't just appear out of thin air. It was forged in the heart of an ancient star and blasted into the universe when that star finally met its end. But the real kicker? At 2023 ADSV isn't the only one. There are probably countless other ancient supernovas out there, their light still on its way to us across the vast expanse of space. We just haven't seen them yet. And if this one was already rewriting what we thought we knew about the early universe, imagine what else is still out there, waiting to be found. Think we had the early universe all figured out? Think again. The James Webb Space Telescope, JWST, just flipped the script on everything we thought we knew about the first stars and their explosive deaths. For the longest time, Scientists could only guess what those ancient supernovas looked like, relying on theories and models to piece together a picture of the universe's earliest days. But then along came AT 2023 AD-SV, a discovery that flat out refuses to fit neatly into those old ideas. If this massive explosion happened, how many others are out there that we've completely missed? That's the kind of question that keeps astronomers up at night. And here's the kicker, this is just the beginning. The JADES program, using JWST, has already uncovered over 80 ancient supernovas, each one a potential goldmine of information about the universe's past. Every new explosion they spot adds another clue to the ultimate question. How did the first stars come to be? What kind of life cycles did they have? And what did their violent endings leave behind? One thing is certain, these stars weren't just cosmic ornaments. They were the architects of everything we see today, shaping the very galaxies that would one day host planets, life, and eventually us. Scientists thought they understood how stars lived and died, but at 2023 AD-SV proved them wrong. But let's talk about at 2023 AD-SC for a second. This isn't just some random explosion lost in the void, it's a complete outlier. Sure, it shares some traits with more recent supernovas found in untouched metal-poor regions, which tells us that some cosmic patterns repeat themselves across time. But that's where the similarities end. At 2023 AD-SV is an entirely different beast, a celestial firework so over the top it makes other supernovas look tame by comparison. If the universe had a way to turn everything up to 11, this would be it. And it begs the question, if something this extreme happened once, how many other mind-blowing events are lurking out there, just waiting to be found? That's where JWST comes in. Until now, our telescopes weren't even capable of detecting these ancient blasts, thanks to all the dust and distance obscuring them. But JWST, that thing is cutting through cosmic fog like a hot knife through butter. Its infrared instruments can peer deep into the past, unearthing evidence of long-dead stars that were supposed to be beyond our reach. And if this is what we're seeing after just a short time using the telescope, imagine what we'll find in the next few years. This is barely scratching the surface. The universe is full of long-forgotten stellar ghosts, and JWST is about to drag them into the light. But don't get it twisted. This isn't just some history lesson about the early universe. These discoveries matter now. Every single supernova we uncover helps complete the picture of how everything came to be. Every burst of light from a dying star tells a story about the building blocks of reality itself. JWST isn't just showing us the past, it's helping us connect the dots that lead all the way to the present day. The formation of galaxies, the birth of planets, the ingredients for life. It all starts with the explosive deaths of stars like these, and yet we still don't have all the answers. If AT 2023 AD-SV is proof of anything, it's that we've been underestimating just how wild and chaotic the early universe was. What other kinds of cosmic phenomena have we been completely missing? Could there be even bigger, stranger explosions out there waiting to be discovered? The universe isn't done surprising us yet, and JWST is just getting warmed up. Here's where it gets even crazier. If this one discovery has already rewritten what we thought we knew, what happens when JWST starts finding more? And it will. This telescope is designed to detect the faintest signals from the dawn of time, and there's no way this is a one-time fluke. At 2023 AD-SV is likely the tip of the cosmic iceberg. The deeper we look, the more we're going to realize just how much we've been missing. Think about it. How many other cosmic events have come and gone while we were blind to them? The universe is massive beyond comprehension, and for the longest time, we've only been able to observe a tiny fraction of its history. Now, with JWST, we're opening a window into an era that was once completely out of reach. The amount of knowledge we stand to gain is almost overwhelming. But let's circle back to something even bigger. If these discoveries are already pushing the limits of our understanding, what does that mean for the future of astronomy? Are we on the verge of uncovering something even more groundbreaking? Could we finally be closing in on the remains of the very first stars, the ones that started it all? These are the kinds of questions that are about to define the next era of space exploration. And the best part? This isn't just a bunch of scientists geeking out over numbers and data. This is the story of the universe itself. This is about where everything came from, how the cosmos evolved, and ultimately how we got here. We're living in a time where these answers are finally within reach, and that's something truly incredible. If at 2023 ADSV changed what we knew about space, the James Webb Space Telescope is about to reveal even bigger surprises. The James Webb Space Telescope, JWST, has been turning the universe inside out, delivering discoveries that leave scientists scratching their heads. What it has found so far? Well, let's just say the cosmos isn't playing by the rules we thought it was. Take the distant galaxy JWST 14, CERO. According to what we knew, galaxies weren't supposed to exist this soon after the Big Bang. Yet here it is, shining bright just 290 million years after everything exploded into existence. This one discovery alone forces astronomers to rethink how fast galaxies can form. If galaxies were popping up this early, what else did we get wrong? And then there's GSNDG 9422, a bizarre galaxy that seems to glow from within. Scientists suspect this could be due to population 3 stars, hypothetical giants from the universe's childhood that were supposed to be long gone. If these stars still exist, that's a game changer. These are the first ever stars, burning hotter and brighter than anything we see today, and they were thought to be extinct. But now, thanks to Webb, we might have to rewrite that chapter in the astronomy books. Black holes are another cosmic wildcard, and JWST found one that's a real head-scratcher. Here's 1019 is the oldest, most distant active supermassive black hole ever seen, lurking in the early universe just 570 million years after the Big Bang. Here's the catch: it's smaller than expected. Normally, black holes of this age are far more massive, which raises an uncomfortable question. How did this one grow so big, so fast? Something doesn't add up, and Webb's just getting started. Then we have rogue planets, free-floating planets just drifting through space with no sun to orbit. The Orion Nebula turned out to be a hotspot for these lost worlds. Even weirder, some of them come in pairs, forming binary systems despite being completely untethered from any star. These so-called jumbos, Jupiter mass binary objects, shouldn't even exist according to current models of planet formation. Yet, here they are, floating around in deep space like cosmic rebels. JWST isn't just looking at galaxies and planets, it's also uncovering the chemistry of the early universe. It recently spotted organic molecules in a galaxy over 12 billion light-years away. That means the basic ingredients for life were already forming when the universe was just a fraction of its current age. Life, or at least the potential for it, might not be as rare as we once thought. Could it be lurking in the far reaches of space, waiting to be found? On top of all that, Webb's taking the most detailed pictures of galaxies we've ever seen. The Phantom Galaxy's spiral arms, for instance, are packed with complex details that show how stars are born and how galaxies evolve. Each image rewrites what we thought we knew about cosmic structures, bringing us closer to understanding the grand design, or lack thereof, of the universe. When it comes to exoplanets, JWST is proving to be a game changer. It found water vapor in the atmosphere of WASP 96b, a gas giant over 1,150 light-years away. That's right, water out there, in space. While it doesn't mean life exists there, it does mean that conditions for life-friendly planets are more common than we thought. And that's just one of many exoplanets Webb is analyzing. Then there's the Southern Ring Nebula, a ghostly cloud of gas and dust expelled by a dying star. JWST's detailed images show what happens when stars die, and it turns out there's a whole lot more going on than we realized. These observations help scientists understand how stars live, die, and give back to the cosmos by scattering the elements that make up new stars, planets, and even us. One of the biggest surprises? A Type Ia supernova, SNH-P, captured at an extreme distance. This kind of exploding star is used to measure cosmic expansion, and this one might help solve the long-standing question of why different methods for measuring the universe's expansion rate don't agree. Is the universe expanding faster than we thought? If so, why? These are the questions keeping astronomers awake at night. JWST has also turned its lens on Jupiter, snapping images that show its rings, moons, and swirling storms in greater detail than ever before. Even a planet we thought we knew inside and out is full of surprises. The data Webb provides could help us understand not just our own solar system, but planetary systems beyond it. Galaxies, black holes, and planets. JWST is not just teaching us about the past, it's showing us things that could change what we know about space. Meanwhile, in the Tarantula Nebula, a hotbed of star formation, Webb's infrared eyes have uncovered countless young stars hidden in dense clouds of gas. This gives scientists a new view of how stars are born and what conditions create them. If we want to understand how the Milky Way and other galaxies continue to produce stars, this is where we start. And it's not just planets and stars. Webb's been studying the misfits of space too. Brown dwarfs, objects too big to be planets but too small to be stars, were spotted with surprising companions. One was found with a planetary mass object orbiting it, something that defies our understanding of how binary systems work. The more Webb looks, the more it finds things that shouldn't exist. Galaxies colliding is another spectacular show JWST has captured. The Penguin and the Egg, two galaxies caught mid-merger, provide a cosmic crash course in how galaxies evolve over time. These interactions are crucial to understanding how galaxies like the Milky Way came to be. And Webb is watching it all happen in stunning detail. Webb's infrared vision is also allowing it to peer through thick clouds of dust that block visible light, revealing hidden galaxies and star-forming regions. This means we're seeing parts of the universe that were completely invisible before, filling in missing pieces of the cosmic question. The James Webb Space Telescope is turning its powerful gaze toward Uranus, and what it's finding is changing the way we see this distant ice giant. The telescope has captured the clearest images of Uranus's rings and atmosphere in many decades, revealing details that scientists have never seen before. Unlike the massive gas giants Jupiter and Saturn, Uranus tilts on its side and has a strange, almost eerie appearance. Scientists have long wondered why this planet is so different from the others, and Webb's latest data might help answer that question. The more we learn about Uranus, the more we realize just how little we understand about the frozen worlds in our solar system. But Webb isn't just focused on planets. It's also looking deep into the oldest galaxies ever observed. And what it's finding is making scientists rethink everything they thought they knew. Some of these ancient galaxies seem far too large, far too bright, and far too advanced for their age. According to what scientists believed about the formation of the universe, these galaxies should not exist in the way that they do. If galaxies could form this quickly, what else have we misunderstood about the earliest days of the cosmos? Webb's discoveries are forcing astronomers to rewrite their theories about how galaxies are born and how they grow over time. Every new image from the telescope brings a fresh challenge to the rules scientists once thought were unshakable. Even beyond that, Webb is diving into some of the biggest questions in all of space science: dark matter and dark energy. These two invisible forces make up most of the universe, yet no one has ever directly observed them. Scientists only know they exist because of the way they shape galaxies, pulling and stretching space itself. By mapping how galaxies move and interact with one another, Webb is giving scientists new ways to test their ideas about these hidden forces. And with every new piece of data, the debate about what dark matter and dark energy truly are only grows more intense. If these forces have been shaping the universe since the very beginning, then understanding them could reveal more about the nature of reality itself. On top of all this, Webb continues to capture breathtaking images of nebulae, massive clouds of gas and dust where new stars are born. These colorful regions of space are filled with the building blocks of planets, moons, and even life itself. Webb's detailed images of these cosmic nurseries show how powerful explosions from dying stars spread elements like carbon, oxygen, and iron across space, seeding the next generation of solar systems. Every time Webb sends back a new image of these glowing clouds, it challenges what we thought we knew about the way stars and planets form. Just when scientists believe they have figured out how the universe works, Webb's discoveries prove that space is far more unpredictable than anyone ever imagined. The universe is bigger, stranger, and far more chaotic than we ever imagined. And thanks to the James Webb Space Telescope, we're only just beginning to see how much we still don't know. What other mind-blowing discoveries are hiding out there waiting to be uncovered? Is this ancient supernova just a glimpse into the past? Or could it reveal something far more dangerous lurking in the depths of space? If stars this massive shape the universe, could they also destroy it? Scientists are only beginning to understand the full impact of these cosmic explosions, but what if the next one is closer than we think? Tell us what you think in the comments, and don't forget to like and subscribe for more.